Mesopotamians were the first astronomers to make long-term written records of their observations. They created ziggurats, pyramid-like towers that represented the different planets as their observatories. They used the placement of the stars and planets to keep track of yearly cycle, which was extremely important to the agriculture of their community. The Egyptians used the stars to make calendars to mark the events, such as the Nile flood. They built structures such as the pyramids to respect the alignment of the stars, to help with direction, and to align with specific events, such as the summer solstice. The reasoning for the stone hinges is a mystery, but the most common theory is that it was used as a big clock to determine the time as well as the time of year. The astronomers of China made highly detailed records of celestial events, such as the comets and eclipses, over the course of 2,600 years. They discovered Halley's Comet in 466 BC, a comet that still orbits the Earth today. Stiles was a merchant who traveled to Egypt to gather ancient knowledge, where he learned to measure distance and how to measure things using the shadows it casted. Stiles became so good at this that he was able to predict an eclipse that ended the battle between the Lydians and the Persians. Pythagoras and his students used models to explain their theory that the Earth and other planets were spherical and moved in a circular motion. Pythagoras himself left no writing, so it's difficult to pinpoint his theories. He also had the theory that the Earth orbited around an eternal flame in the middle of the galaxy. The Babylonians used records set in place by the Mesopotamians to find patterns in the moon and put them to separate periods. The reason they did this was because they believed that these patterns influenced Earth. This belief is called astrology. Aristotle was a student of Pluto who proved that the Earth was in fact a sphere. He discovered the natural elements of Earth, which are earth, wind, fire, and water. The heavier these elements move towards the Earth, the lighter it moves up towards the sky. Aristarchus found the equation to find the distance of the moon using geometry, though he never fully found it because he thought it was a waste. Eratosthenes found the size of the Earth using geometry and the sun. Hipparchus' contributions were the refinement of Aristarchus' method of finding the distance to the sun and the moon. He improved determination of the length of the year and extensive observation and theories of the motions of the sun and the moon. In 134 BC, he discovered a new star, Nova. The Mayan monuments and buildings were aligned to the position of the sunrise and sunset at the equinox and solstices. Venus was important to the Mayans. Significant cultural events, such as battles, were timed to coincide with particular positions of Venus. To keep track of the changing positions of Venus, the Mayas aligned buildings and built lines of sight pointing towards the northernmost and southernmost rising of Venus. They also prepared extensive tables of rising of Venus and of lunar and solar eclipses, which they were able to predict in advance. The extreme complex calendar of the Mayans kept track of not only the sun and the moon, but also the rising and setting of Venus. Ptolemy worked in Alexandria from about 127 to 151 AD. His accomplishments were the completion of the system that could accurately account for the motions of the planets by using a combination of regular circular motions.
After this one, you can just...
The Islamic astronomers improved many observing techniques. They also improved the way in which planetary positions were calculated. The main contribution the Islamic astronomers made to the development of astronomy was the preservation of astronomy of the ancient Greek. They translated the works of ancient astronomers, including Ptolemy, from Greek to Arabic. They were the first to build observatories that were organized, equipped like their modern counterparts. The observatories had instruments to measure the positions of celestial objects, timekeeping devices to mark the time of observations, and libraries of as many as 400,000 manuscripts. Nicholas Copernicus developed the first heliocentric model of the solar system. He studied at the University of Krakow, where he learned the details of the Ptolemaic system. After returning from Italy, Copernicus wrote an outline of a sun-centered theory of the solar system. His theory would have never been if it wasn't for a German astronomer, George Hipparchus, reading it. Tycho Brahe wrote a book describing an extremely bright star, Nova, when he was 26 years old. Brahe's accurate observations led him to reject the heliocentric model of the solar system. Brahe looked at the stellar parallax, the annual apparent change in the position of the star, caused by the motion of the Earth around the Sun. Tycho finally shared that the Sun and the Moon orbit the Earth, and all the other planets orbit the Sun. Thus, Earth is stationary. His model was in general use for about a century after he died. In 1564 AD, Galileo improved the telescope, giving it a range 20 times of the original. He also discovered the moons of Jupiter and the faces of Venus, which started proving the heliocentric method. In 157 AD, Kepler came up with the laws of planetary movement. The first law is that planets will orbit within ellipses with the sun at the center of one of the two focals. The second one is that the planetary orbits are faster when closer to the sun. And the third is that there's a relationship between the distance and time for orbiting the sun. In 1646 AD, Newton created the laws of motion. He also discovered the universal law of gravitation, and he created calculus. In 1652, Edmund Halley discovered the period of the Halley's Comet, which was roughly every 76 years. Albert Einstein's theory of relativity was proposed in 1905. It extended Newton's mechanics to a large speed, close to the speed of light, describing changes of measurements of physical phenomena when viewed by observers who were in motion relative to the phenomenon. In 1915, Einstein extended this theory further in the general theory of relativity, which includes the effects of gravitation. This theory states that mass and energy determines the geometry of spacetime, and curvatures of spacetime manifest themselves in gravitational forces. Niels Bohr discovered, along with some colleagues, the structure of the atoms and created the Bohr atomic model in 1913, which states that electrons travel around the nucleus in a discrete orbit. In 1922, Niels Bohr was given a Nobel Prize in Physics for his work on the structure of atoms at the age of 37. Wolfgang Pauli received the Nobel Prize in Physics for his discovery of the Pauli exclusive principle in 1925, which states that in an atom, no two electrons can occupy the same quantum state simultaneously. Werner Heisenberg is most famous for his uncertainty principle, which states the impossibility of knowing exactly where something is and how fast it is moving. But this principle is only valid for tiny particles such as electrons. Edwin Hubble made an amazing contribution to astronomy when he discovered the galaxies moving away from us. This theory, known as the Hubble law, states that galaxies recede away from each other at a rate proportional to their distance from each other. This concept is a cornerstone of the Big Bang model of the universe. George Lemaitre is usually credited with definitive formulation of the idea of an expanding universe, now known as the Big Bang Theory in 1927, which he himself called his comet egg. Robert Oppenheimer was an American nuclear physicist who worked on research for the atomic bomb, but he is most known for being the sole creator and inventor of the nuclear bomb to most people in the world. Fred Hoyle was a believer in the steady-state model of the universe and thus did not believe in the Big Bang Theory. He was, however, the one who coined the term Big Bang, and he did believe that early life forms were transported by comets. Penzai and Wilson received the Nobel Prize for making the discovery of the cosmic microwave background radiation, or CMB, which provided evidence of the Big Bang. These astronomers were using a large horn antenna in 1964 and 1965 to map signals from the Milky Way when they found the CMB. The CMB is said to be noise left over from the creation of the universe. Armstrong was the first person to set foot on the moon, and Aldrin was the second on July 20th, 1969. They spent 2.5 hours exploring the moon's surface in a gravity only 1/6 as powerful as on Earth.